Thank you for coming to session 2 of track for our afternoon session. And we're going to focus on DAS and indoor small cell network management aspects. Let me quickly jump into the introduction. I'm going to ask each of our panelists to take about 2 minutes to tell you about themselves and about their company. Why don't we start with Ray?
Good afternoon. My name is Ray Albertson. I work with Netscout as a product manager. Been there for about 2 years now. Prior to that, I was with various operators, both within the UK and the US. Within the operators, we deployed a lot of small cell solutions, mostly within the European arena.
Thank you. And tell us about Netscout. What specifically
Sure.
Netscout
Netscout is a probing company. We monitor both enterprise and wireless networks from a core down to a RAN perspective. So provide visualization from signaling, RAN analytics, RAN optimization, and geo analytics.
Is it mainly on the LTE side, or you also do 3G and Wi-Fi?
No, we actually provide everything from 3GPP specification, so CDMA, UMTS, GSM, and LTE.
And it's on the radio level, not at the IP traffic level?
No, we also do core network IP monitoring.
So end-to-end?
And end-to-end, complete end-to-end, RAN, IP, enterprise. Yes.
And who are your customers typically?
It varies. A lot of operators.
Operators
mostly that I deal with from a RAN perspective.
Not neutral host providers?
Not neutral, no.
Okay. So Matt, tell us about Savone and tell us about yourself. What do you do at Savone? A little bit background about your expertise and then what the company does.
Sure. So I'm Matt Goldberg from Savone. I run Global Solutions, which includes all third-party integrations. In addition to that, I also manage our systems engineering team for both the CSP, so communication service provider market, and the managed service provider market globally. Savone's focused on providing infrastructure performance management, kind of leverage 3 pillars of data collection to provide carriers insight into exactly what's going on in their infrastructure. So we look at it from collecting metrics, logs, as well as flows from the infrastructure to provide them that visibility.
Is it mostly IP level?
Mostly IP, yeah. I would say 90.
And is it strictly on mobile solutions, or you do all kinds of?
We do all kinds. I mean, we tend to do best in very large, complex environments. So the majority of our customers are carriers or customers that operate carrier-like environments. So large global banks, manufacturing, those types of.
So I know Savone is a sponsor of Tower Sales Summit. Thank you for that. Tell us a little bit about the company. How old is it? How many people?
Sure.
Where are you based?
Yeah, absolutely. So the company is about 10 years old. Headquarters is in Boston, Massachusetts. We have a technology innovation center in Newark, Delaware, which is where the founders went to college. It's actually on the campus of University of Delaware. We're about 500 employees worldwide. The majority of them sit in our technology and innovation center in Delaware.
Thank you. Kashif Hussain, tell us about Prv Solutions, where it came from. I think it's an evolving company with some history. And tell us about yourself.
So Prv Solutions, actually, we rebranded ourselves last year in August. If you've heard of it, from JDSU.
JDSU, of course.
So JDSU was a pretty big company in optical testing and optical components and what have you. But we actually did our test and measurement part of the business. We moved that and called it Prv Solutions. And when I say test and measurement, every interface that you have in a network, we test that. Whether it's an RF interface or it's a fiber interface, a copper interface, what have you. I mean Ethernet or assurance perspective. If you think about it, we have products which do IP analysis as well as we have RF test products. Again, fiber testing. I mean, the whole suite. I can safely say assurance or test and measurement instruments. We cover both and end-to-end pretty much. As far as our customers go, we have operators, NEMs, basically neutral host, consulting companies, what have you. So we cover the whole range actually.
So just to make sure that the audience and I better place you in the scheme of network test equipment and monitoring and optimization, neither one of you do what Rohde & Schwarz does, right? They do signal level, RF level monitoring. That's not what you guys do.
So there is also a difference between us and road insurers. So we do compete with road insurers as well when it comes to RF testing. For example, I mean, they have some products like for sweep testing, for interference hunting and all that stuff. So yeah, we play in that space as well. But there are certain bands in the microwave and whatnot, that's where we don't play, but they do play. And there are some lab aspects of it where they are and we don't. But other than that, like from a cellular perspective, when you talk about, let's say, the operators of the world, service providers, so what they deploy, we actually compete with Rode and Albertson and those guys as well. So we do play in the RF space as well, but we don't do all the full spectrum, I would say.
Okay, so when it comes to DAS systems, and if we're looking at interference mitigation and all of those, out of the three, it sounds like Savone doesn't touch interference. Netscout?
Yes, we do, yes.
You do. Tell us
we
about
do.
your solution on how do you measure and quantify and deal with interference in DAS systems, especially in places like stadiums and high-density venues where antennas are so close together with no walls to separate them.
Yeah, so the system that we actually deploy and use is based around about the NEM 333P CTR specification. From that, we receive information using PM measurements. Using those PM measurements, we then collect that data, monitor it on a per cell basis, and then generate cell-based and even subscriber-based information that allows you to pinpoint where interference is coming from. So you can actually do it from a geographical map perspective, and you can see hotspots of interference, be it from small cell, macro cell, or otherwise.
Does your equipment sit in the network, or does it sit out in the field where it's
No,
receiving RF
it
signals?
sits in the network.
In
So
the
it's
network.
actually receiving information from the base station. The base station
Okay.
is transmitting this information to us. We receive it, decode it, and then analyze it and present it in a graphical form.
So is there any specific things you do that are unique for DAS, or is it your general macro solution that also works on DAS?
Exactly, yes. The solution actually works on multiple various scenarios, DAS being one, but it is also transferable across to macrocellular as well.
Okay. And Matt, that's not what you do. You
No.
don't look at RF. Tell me about what level of optimization and monitoring you do, and how do you recommend fixes? Do you do the fixes, or you simply report the problems?
Yeah, so we're more on the reporting side for sure. So what we do is we'll collect the data from each point in the network. So from whether it's the radio access or in some cases the fiber that's feeding it, and then being able to report back, what is the signal strength, how many connected users are there, what is the actual throughput on the different frequencies and those types of things. From there, what we can do is trigger upstream alerts and alarms that, either carrier can have automated into an automated system that would automatically take action. We have some things, not exactly in this particular arena, where we actually do complete a feedback loop. So we'll collect the data, make intelligent decisions on behalf of a customer, and then pump that data back into something else that's consuming it, like an orchestration engine. In a lot
Is
of
your
cases.
solution used once during the design deployment, or it's used all the time during the lifetime of the network?
It's usually the lifetime of the infrastructure. I mean, part of it is understanding, from a capacity perspective, where am I today, tomorrow, and next week, and collecting the metrics over a period of time to allow you to understand what are the trending capacities and understand from a planning perspective, this is where I am today at the current rate of growth that I have in terms of subscribers or traffic. This is where I need to be, I need to add additional capacity in whatever form that is, whether that's the backhaul on the backside or, certainly the wavelengths and the frequency on the front side of it, if you will.
And does your solution sit in line with traffic, or do you sit as a probe and
I would say
sniff on the traffic?
Yeah, we sit more, I would say, horizontal to the traffic, so we're not in line. We could sit in line if someone wanted to. We don't have a single deployment globally that is in line, though.
So on a given network where we have 10,000 base stations, how many of you boxes or probes do I need?
Yeah, it depends on how much traffic and how much you're monitoring from each individual base station. I mean, we have some carriers in North America that, have, 200 of our boxes, in a combination of both physical and virtual to manage their entire infrastructure. But in that case, you're looking at, upwards of 100,000 devices. So.
And is your business model to sell equipment and, one-time fee, or do you charge annual software upgrades?
Yeah, so
over that?
yeah, we deliver the solution really as software. So we do deliver as an appliance if a customer wants, physical or virtual, and we have capability to do most purchase, it, out of capital, and then pay maintenance yearly. We do have some that just run it on an OpEx, so they pay monthly or yearly for the solution.
So it's a network appliance. It can be virtualized. It has probably a multi-gigabit internet interface and probes and gathers statistics. Give me some examples of what data you gather and some success stories on how you help an operator, specifically if you have one in the DAS area, that led them to take some corrective action.
Yeah, sure. So we do a lot of work with some of the carriers in the U.S. Obviously, for those of you that we were chatting earlier today, you get large global events and you look at specifically things like stadiums. So what we'll do before an event, something like the Super Bowl, we'll work with the carrier to actually map out the entire footprint of the DAS and the small cells within the particular stadium, and then where the backhaul pipes are coming in, and actually start looking at it, a couple weeks in advance, because typically we find at large global events like the Super Bowl and other things, they do have events leading up to it that can, in some cases, give you a good leading indicator of what may or may not happen come kind of prime time, if you will. So in this particular case, with the Super Bowl last year, we were able to identify a couple of spots in the stadium where there was zero coverage. It just happened to be the angles at which some of the antennas were placed. Carrier went in and actually, made some adjustments before game time, so to say, and we were able to help them identify that in advance of the game.
So clearly, when you take an empty stadium and people start showing up, and by the time it's game time, we have 80,000 people or whatever in a stadium, traffic grows and peaks and stays peak at that time. Besides saying that, yeah, the sensitivities of how the network is going to perform is at the peak level, what guidance have you given your customers that has led them to take corrective action? And what are corrective actions? Are corrective actions to put more sectors, or what can they do to make things better?
Yeah, I think in a lot of cases it's really up to them what they want to do to make it better. We kind of leave it in the hands of them. We're certainly not the experts on the antennas and some of the DAS pieces. From our perspective, it's more identifying for them where the problems are before they have a problem. Is kind of how we look at it. We like to be kind of in that predictive or proactive nature of here are hotspots or here are where we see problems. I mean, we look at things like, throughput, packet loss, latency, jitter, some of those types of things, which I know you guys look at as well, to really be some of those leading indicators. Even if it's an empty stadium, you got 5 people in there, and you have packet loss through the roof. As you can imagine, when you start putting 80,000 people in there, it's only going to get worse. So how do you handle those saturation at that peak time? You look at, another great example is college football stadiums come game time on Saturday, where you put 100,000 people in a stadium for 4 or 5 hours and then they all walk out. I think part of the challenge that carriers have, and you were talking about it on the previous panel, how much do you invest in that, for this, very short window of time, 10 times a year. So I think it's a balance that
So are you doing deep packet inspection?
No, we do not.
You're
That
not?
would be these guys over here do DPI.
Okay.
Actually, you guys do too.
Yeah.
So,
Okay. So, Kasia,
Good
tell us
advertising, thanks.
about
no problem.
what data you gather and what recommendations you make for both DAS and Wi-Fi systems so that people can improve their system.
So from a DAS perspective, if you look at it, so I would say there are multiple layers of testing that happens. If you take the life of a DAS from the point of when you have to install the DAS, right, you have to help the operator in understanding what the baseline coverage is, and when you do a DAS, what are you trying to improve? If it's the capacity aspect of it, where your antennas need to go. So once you have finished your IB wave design and all that stuff, and then your integration happens, we work through all that process. Now let's go into the optimization aspect of it. For example, let's say Levi Center was getting optimized by one of the tier 1 operators, right? So in that case, what the solutions they use, right? So they use multiple things from our product line, right? For example, they use our Rubik solution for real-time data collection and analysis. They used our TrueSight tablet, which was basically their engineers. Actually, they were half an hour before the event started, they were collecting that data and making those decisions. We also have a Arisio product, which is which sits in the network and which can collect data. In this case, it was not used, but we do offer that solution as well. But basically, what they used in this example that I was giving you about the Levi Stadium, so basically using our TrueSight tablet, collecting that data, using our real-time basically analytics solution, and trying to identify any throughput problems, and also at the same time, they were able to compare their network with their competitors and see where they stand. The profile of the solution, the TrueSight, is so small that they were able to even walk during the event, and they totally managed it throughout the event, how the performance was looking like in the network at that point.
So what was the recommendation? Was the recommendation to buy more base station sectors, or was the recommendation to put a cache?
Actually,
for latency? What was the outcome of all of that?
Okay, so when they did it about a few weeks before, they had to retune the network. So for example, if you have to make tilts to the antenna, or if there is a challenge with or some issue with one of the antennas or whatnot. So we have built-in features which were able to help them identify if certain antennas in the network are not performing well. For example, if I'm expecting antenna number 1 to have a certain RSSI at a certain point based on my design, but when I walk through it, I don't see that, so it indicates that there is a problem. So they were able to look into that, they were able to fix that. Even close to the time when the event was going to happen, they were able to test the whole network, and they were able to see if they have to make any down tilt, or they have to make any changes to the network. So they were able to do that. That's just one example. But in general, any kind of DAS or in-building environment, you can offer that testing. Going to the next level, where our Arisio solution also comes in, it actually can help you in identify where you need to deploy the next small cell. I mean, is it really just because it's a coverage problem, or you can just look at your whole network and see where you have those red spots? When I say red spot, meaning where you have those coverage gaps or capacity gaps where you are seeing those problems. In fact, the solution also helps you in what we have built is kind of a self-organizing and self-healing aspect of it as well, where we offer those recommendations to the customer that maybe you need to, reduce the power, reduce the pilot power, you're interfering too much and whatnot. And we have use cases where we have helped the customer significantly in those use cases using that solution.
So you mentioned self-organizing.
Mm-hmm.
That's typically the function of the DAS equipment vendor or even the base station vendor, not a standalone solution. Are you saying your solution does that?
On the macro side, we actually help in identifying that basically if you have a neighbor relation problem and that stuff, you can use that to basically then correct those problems. Because you're absolutely right. So in the DAS side, we don't have any control of that. When I was talking about this from a macro to a small cell type network you're talking about, then in that scenarios, if you have neighbor relation problems, you can help them with that. So they can basically improve their neighbor list and things like that.
So are you aware of SON or self-organizing network solutions for DAS, specifically DAS? Do any of you provide that?
Not specifically. We don't provide a solution. But what we do provide is a non-vendor specific feed into SON. One of the issues that we are seeing repetitively is when you have Nokia, Ericsson, for example, that are generating their SON system, it's very specific to their equipment. What we provide is per subscriber location-based information to the SON system to enhance their algorithms.
And where do you get the per subscriber location-based information?
That was from the aforementioned cell trace data. We're also working on the MDT specification feed as well, the 3GPP. So when that gets launched by the operator, we'd also get information directly from the handset. But currently we get all the information from the eNode B itself, from this cell trace function.
Most operators also have deep packet inspection platforms that are used for billing and accounting and policy purposes. You coexist for them, with them?
We do feed into various PCRF functionality with DPI, service provision and service optimization. That's typically something that a lot of operators are not doing actively right now. It is something which they're interested in, but from a service provision perspective, there is a lot of optimization from an end-to-end perspective going in from the operator side.
So tell us about your TrueCall RAN solution. It's called GeoAnalytics.
Yes.
It's a platform that enables operators to streamline.
Yeah, so it's a real-time tool that can be connected to all your sites for the full network. It's all year round 24/7 analysis tool. It can be used for multiple applications, including optimization, small cell location placement, fault finding, subscriber issue tracking, and VIP tracking. It uses the cell trace I mentioned already. So depending on the vendor, there's various proprietary information which is sent from the eNode B to our probes. We extract that, create analytics on this, so it's actually create our own KPIs, create our own analysis, and then also generate heat maps from that too. So you get visualization of a high granularity, even down to potentially 50 to 100 meter granularity of where your traffic is, where your traffic's not, any hotspots, not spots, or equally as well where you've got RF interference issues or even KPI issues.
So if you installed in a venue in a desk system, you're only monitoring one operator, or do you sit at a place where your solution monitors or 3 or 4 operators?
Typically our solution is deployed within a switch location. At that
per
point,
operator?
You can have it per operator, but you can also have multi-operator as well. So we do have multi-operator solution where you can actually look at a network which might be Ericsson and Nokia, for example, and then do a comparison between the performance of the different operators. We also do device analytics as well. So if you want to look at performance of certain devices within an area, you can
like
do that.
iPhones and...
iPhone versus Samsung or otherwise, yes.
Okay. And
So,
when you have a solution that's vendor-specific, you need to query the base station, get its data for you to have the information. You need to integrate with those?
The network manufacturers actually provide 2 mechanisms for us to receive the cell traffic. It's either streaming, so we're receiving the data real time, and then you can actually see the traffic real time, or there's file-based. Generally, it's depending on the network equipment manufacturer themselves as to how they actually provide that information. And as I said as well, we're also looking at MDT, the 3GPP specification for MDT, and that would come across in that same stream. So it would still be file-based or streaming-based.
So when you go to DAS meet me room and there are 4 operators, each one has their own vendor or vendors. For one spectrum they may have one base station, another one they may have another. Are you certified with all of them? Is there a standard interface with all of them? How do you monitor 8, 10, 12 different base stations?
So the base station themselves, talking about different
Different frequencies. Let's say 700 is
Okay.
by Alcatel.
The frequency doesn't make any difference. The information that you receive from a particular vendor is specific to that vendor.
Okay,
It's only the content within that message itself changes.
But AT&T may have 2 vendors at a location.
Okay.
Right,
So-
because their 700 is with one vendor, their AWS may be with a different vendor.
Yeah. So regardless, if we support all the major
You do support all of the major
yes,
LAN
vendors.
vendors. What about
Yes.
small cell vendors?
Small cell vendors are just starting to get into this CTR specification. There are some small cell vendors who are also generating the CTR, and we do support those too. So, for example, like Airspan, for example.
Okay. Kashif, how does your company enable operators to streamline this whole network densification?
So it depends which part of the network we are talking about. So it can be from a macro perspective or a DAS or a small cell, right? So if we just talk about the macro, so things have changed in the macro in the last, like I would say, few years, right? Where you have to have the conventional cell sites. Now we have fiber to the antenna cell site. If we talk about DAS, then in the DAS scenario, I mean, the time it takes to deploy DAS is much longer. And now we've been working with operators in the US, and they've been driving us to look into solutions which can kind of optimize the whole process of installation and commissioning and verification, right? Because the DAS deployment is a very complicated process, and you can have multiple parties. I mean, going from the venue to the neutral host to the construction crew and the contractors who are engaged in that, right? So, I mean, so all that stuff. So in that aspect, we have actually offered a workforce automation solution for the DAS aspect of it, where we have tied our Cell Advisor product and T-Bird solution. That is basically where you can take a design from an IB Wave or a RAN plan type solution and basically directly input into these tools. So as you go from the node, and if you, let's say you have 200 sectors that you have to deploy, so basically the information of every fiber, how long of the fiber will be, what kind of antenna will be, all that stuff which is done in the design is directly imported to these devices. So now you can, when as a technician, now you don't have to get an Excel spreadsheet, go and look at it and get every node tested, take a picture of it and send it out. It all automatically gets uploaded and goes into the cloud. So directly from the cloud, your service provider, basically let's say an AT&T or a Verizon for that matter, they can see how the network job was done. It improves the timeline by about 70% based on rough estimates. In some cases it can be more depending on how complicated and big of a network it was. So that's just the DAS side of it. Now if you look at it from a macro perspective, so where we are talking about the fiber to the antenna, where now you have CPRI interface going CPRI or OPSI. I mean, depending on if you are a Nokia, you have an OPSI interface in there. If you are a Alcatel-Lucent type or the previous one, or an Ericsson, right, where you have the CPRI interface. So we basically support those as well. So RF over CPRI testing, so that from the ground you can actually do all those testing. And before, you used to have the radio and baseband sitting at the ground, right? Now you have moved the radio to the top, and now there are certain functionalities you cannot test when you come back and commission. So if you look at it, your deployment has changed. You go out, deploy the cell site, you install the antennas, you install the radio, you leave the site, NEM comes back, they install the baseband unit, and then the commission happens. And during that commissioning, you figure out, oh, okay, cables are swapped, radio has a problem, software is not there. For that, we implemented a BBU, baseband emulation solution, which actually can do all the testing ahead of time in that regard, so that when you bring your commissioning box at the time of commissioning, you have already eliminated those guys, those problems. So the tower crew who was at the site the first time, they can fix those problems. So that's also part of our automation solution. I mean, going forward, I mean, there are a lot of individual steps.
Tell me the stage where we designed this network, we fixed the interference issues, capacity is good for the first year or two, and then people start walking around with iPhone 7s that have 4K cameras and usage started going up, and now we need to densify more. The point at which you see that need, can you like monitor for that and pre-warn?
Absolutely. So just like, we were just talking about from the Netscout perspective, the TrueCall solution. Similarly, Ariso Geo does the same thing, location-based, not just the individual user basis. Actually, you can also look at how the applications are separately performing as well. So you can get that visibility as well. If you are looking just from the RF aspect of it, again, if the system is deployed into the network of that operator, but usually an operator will have for one region, they will usually have one type of a NEM for the macro network. So let's say you have an Ericsson or you have a Nokia in that case, right? Let's say Verizon, for example, or somebody like Verizon, and they have certain parts, Southern California, much bigger network, what have you, right? and you have an Ericsson network deployed in there, and then you have the partnership with them for example, or just an AT&T, right? And you have the partnership where you have your solution in there. So you can actually identify your hotspots. You can identify where your performance is poor, and you can actually also tell where these applications are performing bad. So you get that granularity. Not just that, you can actually make the recommendations looking at your heat maps and show that, you know what, I mean, and also you can look at different messaging and whatnot and identify the root cause of the problem, whether it is an interference related problem, it's a coverage related problem, or maybe your parameters, something are wrong. Sorry?
Okay. Or capacity.
Capacity, of course.
So you do this on a cellular network. Let's
Yes.
talk about a large venue like this one here. Do you also look at Wi-Fi, and what if the cellular traffic suddenly jumps because the Wi-Fi network went down, or
So we don't have that visibility because...
to Wi-Fi?
Not to Wi-Fi.
Okay, so you're not taking a venue and looking at the venue performance,
Yeah.
you're taking a network and looking at
We're
one
looking from a
network at a
network
time.
perspective, yeah.
That's correct.
Okay,
So,
I would say we look at it from a venue perspective. Or we
you look
have
at a
the-
whole venue perspective.
Yeah, we have the
both on the
capability
Wi-Fi
to-
traffic and tell
Yeah.
me about, you mentioned network visibility.
Yep.
Or application visibility. Tell me what you mean by that, and what can we visualize?
Sure. So I mean, if you look at it like a facility like this, where you've got, you know, a lot of people coming in for a short period of time, or even whatever the particular circumstances are, we look at it, and depending on who the mobile operator is, we have the capability to, if it's their hotspots or if it's the hotspots of the particular venue, we can actually look at, you know, to your point a couple minutes ago, as traffic, if Wi-Fi goes down, cellular traffic's going to go up. So we can actually paint a picture for an individual carrier if they owned both the Wi-Fi and the small cell DAS or the macro that fed this particular region, actually what the traffic composition was and as it transferred. I mean, one of the other things that we're seeing a lot of carriers use us for is Wi-Fi offloading. So understanding as you roam, like Home Depot is a great example, and some of the other large stores in North America, you see that when you walk into some of these places, your phone automatically switches onto Wi-Fi. We actually are showing the carrier, you know, here's what happens when someone walks into a store. Like their data consumption goes down on the mobile side of the infrastructure, and you can actually see, you know, like you look at somewhere like Home Depot, for example, you know, there's zero traffic between, you know, 10 p.m. and 5 a.m. on the Wi-Fi. And then when the store opens, you start to see the Wi-Fi traffic increase, and a carrier in that particular region can actually see their mobile traffic start to decrease at the same time. So from our perspective, it's about collecting all the data for a particular, you know, whether it's a venue or part of the infrastructure, and then being able to understand what's next to it. So in the release that we just put out at the beginning of this year, we have the ability to actually draw real-time topology of what's connected to what using some layer 2 and layer 3 protocols. And with that, what you have the capability to do is pick a point in the network that you want to be your focal point, and then draw out from that. So what's connected from that one individual point, and so you can see what's adjacent to it from an infrastructure perspective.
So let's say you're at a venue like a large campus with 80,000 students that has a cellular network, multiple cellular network, and you're monitoring the traffic on Wi-Fi as well as the cellular networks. The traffic on the cellular network, you can clearly identify which operator they belong to. But the traffic on the Wi-Fi network, do you have visibility to say Verizon customers or T-Mobile customers are using the Wi-Fi network, or how much can you do that?
So if the carrier is doing Wi-Fi handoff to the campus, so like they're ubiquitously roaming from, you know, an AT&T mobile, you know, onto like an AT&T Wi-Fi hotspot on the campus, yes.
If they have that.
If they have that. If they have campus-provided Wi-Fi with their own
Which
SSID.
means the traffic is routed straight to the core again.
Yes.
Then you can do that.
Yeah.
What if it's an independent parallel network?
If it's independent and parallel, we would be able to monitor the two networks separately. We wouldn't be able to say that you went from, you know, using your mobile, you walked into the building, now you're on, you know, Wi-Fi
So you
in
don't
this particular.
you don't give little apps that go on the device that identify the device and all that.
Yeah,
You're solely network-based.
Yeah, we're solely network-based.
And if you're on a campus, do you physically sit in the meet me room Do we need to make room for you, and how much room would you need
Yeah, I mean,
for your equipment?
we could, yeah. We do sit there. We could sit really anywhere that there was connectivity in. So, you know, as I was saying before, we work with a lot of managed service providers. So actually the equipment sits in the MSPs. And then, you know, with the, you know, you look at someone like a Verizon and ATOS, CSC, CenturyLink, all these guys that provide, in a lot of cases, you know, the managed service, but in addition to that, they're providing the last mile connectivity. They already have the pipe going into the facility or the campus. So a lot of times we'll actually collect the data through that pipe back to the managed service provider. So it depends. It's really at the end of the day up to the customer and how they want to procure the product.
I think one of you mentioned, packet loss and retransmissions. Do you keep track of those?
We do, yes.
We do.
Yes.
And what causes packet loss and retransmission usually?
I mean, from our perspective, it depends on where you are on the network. I mean, it could be saturated link, it could be poor signal. You know, these guys see more of the packet level, so it could probably give you more.
Do you see packet loss being a major issue?
Absolutely, yes.
You do?
Everything that an operator measures now these days is what is the user throughput.
And what's the root cause for that, usually? Are they typical?
Take your pick. Anything and everything. The main challenge that operators have now these days is that from an optimization perspective, you have engineers out in the field, and it's the engineers in the market, it's engineers in the field who initially are getting these complaints. They are not aware of what happens after certain conditions. You know, there's RF conditions that can cause packet loss and retransmissions. Then there's also IP configurations, missing routes, et cetera, et cetera.
Or overload, mismatch.
Or overload, mismatch, whatever the situation is, yeah. Server's gone down. The visibility that I think all three of us provide is an end-to-end perspective, so that you can see if it's an RF-related issue, you can see if it's a core-related issue, if it's a certain route issue, and then be able to identify where that issue is and then address it.
So do you recommend caching as a solution to any of those packet loss problems?
They already do caching.
I'm sorry?
They do caching. I mean, you have the TCP layer on top of it where you do caching, but the thing is, how much caching can you do? And there is all timers set up there.
Yeah.
If it gets too much, then you'll start like flushing those packets, and then now you have a much higher retransmission rate. So, I mean, it depends, right? I mean, if it's an RF related problem, yeah, so even in your B, when you were sending the MMEs are sending all this data, yeah, they do keep some track of it at the TCP level, right? But then again, at the end of the day, if it becomes too much, then they flush it. And then now you have a
huge
significant
issue. And latency to deal with.
Exactly.
You get a bigger problem.
Exactly. I mean, if you think about it, right? I mean, it can not just be the RF problem; it can be a core problem where you designed it and somehow you're not assigning the right cache for each and every user. I mean, I've seen problems when the RMC was not really assigned proper caches. As a result, when it was overflowing, it was flushing everybody. So those problems have to be solved too, but you have to find those problems. So it can be many reasons. It can be RF, it can be core, so it depends.
Any questions from the audience?
Just going back to the previous points, one of the issues that I've seen come from an operator side is as we move more into the IP realm, the IT team were very slow to catch up on the impact they would actually have to an end customer. And they were doing maintenance, service changes, route changes during the day, causing huge outages across the network, being IMS or whatever else. So it's taken a long time for organizations to catch up from an end-to-end perspective. And that's really where a lot of the visualization needs to come in. It's, and going back to a previous point in the previous conversation, operators want to provide an end-user quality of service. It's very difficult to do that when you don't have visualization, whether it's going into a Wi-Fi offload, third-party Wi-Fi, et cetera, et cetera. And to sell a service, when you don't have that visualization, you're not able to troubleshoot, not able to visualize where the areas and issues are. It makes it very difficult from an operator perspective to actually guarantee that.
But virtualization is simply moving the problem from one point to the other,
Well,
right?
virtualization,
Is it solving
that's
the problem?
another.
I mean, if you
I
have
would
a
say
problem
that
due to
from
mismatches of
my
capacity-
experience of virtualization, there is going to be a lot of challenges that the operator is going to run into. Specifically where there was some discussion earlier today about centralized RAN, for example, and centralized RAN existing on VMs is going to be a huge challenge for operators, where you have the processing and the capability of that processing being virtualized and passed around different machines. That sort of troubleshooting is going to be very complex, and that's where you need this end-to-end
If
monitoring.
it works, it's good. If it doesn't work, good luck.
It's going to be a disaster, yeah. And you know, there's very clear examples of where virtualization has failed recently, with some of the major outages that have been experienced on IMS cores, even here in the US. So there is a lot of challenges that are coming up with an operator perspective, not only just for an optimization perspective, but also from all of the various technologies they have to deal with in the very short term.
Okay. So Matt, does your solution tell people how much of the traffic belongs to, let's say, Netflix versus video versus, without doing deep packet inspection, how do you get all that information, and how much statistic do you provide?
Yes, so we leverage FlowBased Technology to get that type of statistics without doing deep packet inspection. So, we typically in a provider environment will connect into, or we'll take a feed of flow off the ISP POP ultimately, where they're pumping the traffic out. In a lot of cases, we also look at it incoming to places like the IMS core or aggregation routers as well. And then what we have the capability to do is Flow gives you the capability ultimately to classify traffic, and it's, whether you're Cisco, Juniper, Alcatel, Huawei, you kind of take your pick of the litter from the hardware vendor perspective. Once we have that, we can actually say what IP address the traffic's coming from and where it's actually destined to, and then the type of traffic that it is. Is it video streaming? Is it HTTP? Is it SSH traffic? Whatever. When you look at it, the carriers we've been working with recently, they're looking at it from how much am I spending on an ISP POP perspective. And in some cases, we've seen carriers go out and buy direct connects to places like Netflix, Google, Facebook, Yahoo before they were acquired, where they're seeing tremendous volumes of traffic going to those places. It's cheaper for them over the long period of time to actually go buy a direct connect into their data centers or an AWS than it is to continue pushing it out their internet, out their ISP POP, which in a lot of cases they're buying capacity from someone else over the long period of time. Ultimately it's traffic engineering and making sure that you're routing the traffic appropriately. We've used it in one particular example for a carrier in North America. They were constantly trying to figure out why they had an ISP POP that they had in Southern California was growing at 35 to 55% every week. Well, someone made a firewall rule change in the network, and they took all their traffic that was destined for Facebook and Google and routed it for the entire country out this one ISP POP. So you imagine you're a mobile carrier in the US and you're now taking every single packet that's destined for Google or Facebook and sending it out one ISP POP. You wonder why you went from 10 to 40 to 100 gig pipe in 60 days pretty much. We were able to pinpoint for them, hey, all of a sudden all these IP addresses that were never in this bucket, you're getting Florida IP addresses getting routed out to through Southern California. So
do operators come to you when they have a problem, or they buy your product because they know at some point they need to do monitoring?
Most of the carriers purchase our products in advance. They use it for proactive notification. Typically, we go in and solve a set of problems. I think probably similar to what my colleagues up here do, and then the footprint grows. As you show the different uses of the product within the infrastructure, and that's typically.
Can you give us an idea how much your solution costs?
It really depends on what they're buying, what the volume is, what are they trying to solve? Are they trying to solve a problem in one data center? Are they looking to roll it out across the entire country? We have some carriers that operate in multiple countries, so.
So it's not a solution that, it's not like a test equipment.
No.
It's installed and stays there,
It-
it's constantly there.
Yeah,
Every
yes.
segment of the network needs one.
Yeah, and it grow, typically in, knock on wood, most cases it grows
That's
over
not how
time.
your solution is, right? Or is it the same way?
Depends.
Depends.
You guys depend.
Even in the boxes nowadays, you have licenses, right? I mean, it does
Yeah.
multiple things. You want to
Yeah.
test LTE Advanced, you want to test just the basic LTE features, or you want to put Interference Advisor on top of it. So it all depends how many licenses you're buying, what kind of licenses you're buying. For the network type models, just like what my colleague said here, right? I mean, it depends on how big of a network you're deploying,
Yeah.
how much traffic you'll be carrying. And based on that, you will define how many probes you need to install, right? I mean, how much signaling traffic you have. I mean, looking at all that stuff, then you define the cost aspect of it. So then you decide whether the return on investment is there for you or not. Like, can you live
But in
with
the
it?
case of a DAS network, it sits still in the core, right? You're not physically going out deploying in buildings like this.
What do you mean by that?
Like, your equipment doesn't physically sit in this building if you want to monitor traffic in this building.
Right, so for the
You
DAS
sit on the
side,
backhaul, you sit on the interconnectivity.
but we sit in the core of the
In the
network
core.
operators, the switch you can call it, right? Or where the B's come back and your backhaul comes and delivers the
That's
traffic.
where you sit.
Right,
And the aggregation network. and the core
exactly,
network.
from that perspective, yes.
Okay. Any questions from the audience? Okay, so let's try to summarize and see if we can come to some conclusions. It sounds like whether you're doing radio level monitoring or base station equipment level or IP level in the network, these networks have gotten so complicated that doing DAS and neutral host even multiplies. It has the multiplicity effect of making it even more complex because you're merging and combining 6 to 8 to 12 networks on a DAS in one location. Monitoring and optimizing appears to be an essential part of that process, and without which you can't debug, you can't optimize, you can't even scale your network to the point of knowing when to add capacity and having visibility both on the Wi-Fi side and the cellular side on a per venue basis appears to be a lot more effective than just looking at isolated networks. Do you agree with that?
Yes, absolutely.
And your solutions will be the type of solutions that network operators should be considering to have that.
The alternative is to drive to a site and test it at location. And as more DAS comes up, it might be achievable through a macro, but as more and more DAS buildings come up, it's going to be too much for the engineers who currently exist in the market.
Yeah, exactly. As the small cells and all these things that we are talking about, they are going to grow, right? And when we are talking about the deployment of millimeter wave and things like that, right? Think about it, the number of cells you have to deploy, because the RF propagation is very limited. In those cases, I mean, the truck roll and drive test and all that stuff, that's the thing of the past. It's not
Should be
scalable.
simpler, you're saying.
It has to be. It
Has to
be.
cannot.
Yeah.
It cannot be done that way anymore. Otherwise, your operational cost will be so much higher that
Yeah.
it won't make business sense.
Great.
It has to be.
All right, well, thank you very much for participating
Thank
in
you
the
very
panel.
much.
We appreciate the
Thank you.
insight.
Thank
Let's
you.
give a hand for our panelists.